Hello everyone, this is Nagasruthi Kattula, currently working at Okta. I'm presenting you the AI Secure Cloud CRM, all the architecture lessons from enterprise success, stories, and failures. We'll be walking through different case studies showcasing successes and failures. Um, let's talk about innovation versus security. In this fast paced, evolving era where cloud CRM has just evolved from simple contact management into AI powered personalization engines, we need to think more about what are the threats that it can come along with. So with transformative power comes extraordinary risk. If we have seen the data, about $4.45 million to $12.7 million could be the cost of any security breach incident for an average single cloud um, companies. Um, we have to balance innovation with security, along without compromising on the quality and speed of the deliverable. Um, no size immunity, which means that the bigger the companies are, in previous days, the bigger the companies are, the safer it is, but it's no longer true. There could be fundamental security vulnerabilities in basic design architecture, which leaves the company open to security threats. So scale doesn't mean safe always. So let's go through the case studies, right? Starbucks, which uses multi cloud architecture to limit the scope of threat actors. It has seen 28% retention increase. It's a successful implementation. Capital One. Here we'll learn from the failures of how one error led into cascade of many errors, which ended up in $80 million settlement. Mayo Clinic, again a success story. How Mayo Clinic operates with everyday patient in and out with HIPAA compliance and innovation. There are 76% fewer unauthorized access attempts after the implementation of this architecture. JP Morgan Chase, which is a success again. It has a robust framework on enterprise fraud detection, estimated $5 billion savings of annual fraud, prevention, are the return of investment. So let's go into the deep study. Case 1, Starbucks. Architecture at scale. $16 million daily transactions. So it has multi cloud deployment, which means there is segregation of concerns for each cloud, which means that even if one of the clouds is compromised or if it's gone down, the radius of impact is limited and the necessary measures can be in place. AWS will handle the core transaction processings and payments, and Azure will handle the CRM part along with the machine learning and AI weaved into personalization. So, separation of concerns means a breach in analytics never exposes payment data. So, business impact: 28% increase in customer retention rates, 18.3% increase in average transaction values, 29.3 higher purchase frequency among loyalty customers, which is the loyalty participation goes up 3.7 times above industry average. Security architecture that enables business performance. Now let's see how Starbucks has embedded all of this architecture without affecting the performance, right? One is MFA, ensuring multi-factor authorization is turned on for every user, internal and external, which means every access request verified through multiple credentials. Organizations with MFA are expected to have 91.4% fewer account compromise incidents versus the traditional password only authentication. Tokenization of payments, right? The tokens, raw payment credentials can be harmful if exposed. So they are masked into non-sensitive tokens with system access. Even if even if the threat actor is able to access the system, all they get is tokens, which is not the exact card information. They'll not be able to use it anywhere else. Real-time fraud monitoring, weaving of AI ML into the threat identification framework, which detects the fraud even before the financial impact occurs. Data classification, again the classification of sensitive versus non-sensitive, all the P2 data. This is one of the key controls that every company has to perform. Analytics team operate in sandbox environments, so which means that it prevents all the P2 data exfiltration, even if credentials are compromised. Right, 73.1% consumers share personal data with retailers, demonstrating strong protection, versus only 18.4% with those perceived as inadequate, which is the consumer trust dividend. Let's go into capital one. Now, what caused the failure exactly? The web application firewall settings were misconfigured, which led into the threat actor obtaining the metadata service, which is internal. And through that metadata service, they're able to extract the data by getting the temporary credentials. So if you see, it has a cascading effect of four steps, right? Every step exploited a configuration error, not a zero-day vulnerability. Even if any single layer has been configured correctly, this attack would have failed entirely. So the five security principles which got breached here are zero trust violation, which means having internal access doesn't mean that whoever got access is trustworthy. Every request have to go through authorization again. Here in Capital One, that was not the case. That's why they have been granted a broad S3 access, which is the database. Least privilege violation again. Why do web applications have superior permissions? The web applications should only have limited permissions. If had that been the case, the metadata service would not have been exposed, which led to extracting the data. Encryption at rest is violated, which means the sensitive customer information P2 has not been masked. It's stored unencrypted. So S3 bucket access directly exposed all the raw information. So encryption would have prevented this attack again. Network segmentation violation, which means there's no isolation between functional areas. So no segregation. So once the attacker is in, everything is a free flow. They can move freely across the environment without any restriction. No access request again needed. Continuous monitoring is violated. There is no AI/ML to understand the threat actors' movements. And the breach went undetected. And this came into picture only through external notification, not through internal monitoring, which is again a big failure. So now let's come to see Mayo Clinic, how Mayo Clinic is operating at scale, following the HIPAA compliance. So we find a hybrid architecture here, which is a club of on-premises versus plus the cloud applications. What is on-premise? Any application which is running locally with the infrastructure installed at the location is called on-premise. And cloud versus where you don't have to maintain the infrastructure, the actual cloud companies do in the data centers, and you can scale. Right. So what does it do? Even if the cloud goes down or if there is a threat actor in cloud, sure that the emergency patient services are not disrupted, and the data is back up the site. There are backup sites, so that the customer or the patient is not affected. So one is compliance isolation. Critical patient systems remain on premises, simplifying HIPAA audit requirements, and scalability. Second one is, which is if you have to scale your administration and engagement services like customer reps, it can scale on demand. You don't have to invest in the infrastructure. Disaster recovery. The cloud provides geo redundancy while on premises ensures care continuity. The outcomes achieved: 99.99% uptime across billions of annual patient interactions, 53% improvement in medication adherence for chronic condition patients, 76% reduction in unauthorized access attempts. um, let's deep dive more. Right, how is this model operating? This model operates on four principles, which is zero trust implementation, which is every user and system will require authentication regardless of origin. Continuous verification of identity and device health is implicit. Contextual access protocols, which means it grants access based on the context. For example, clinicians see only patients' data, researchers see certain predefined sets. So, access is determined by the role, geo, the time and day, even their access history. Encryption everywhere. data classification, which means that so the data is classified and all the sensitive data is encrypted. The keys are managed in the health system management, and it doesn't interfere with performance. AI powered threat detection, which means that machine learning is directly weaved into the security framework. Behavioral analysis identifies all the anomalies in conventional monitoring, which would not be that accurate with human monitoring. Enterprise scale fraud detection, which is you know 2.5 billion daily transactions for JP Morgan Chase. How are they doing it? This is using multi-cloud architecture. So previously we saw hybrid architecture. Now we are seeing multi-cloud architecture, which means they use multiple clouds, and every cloud has a segregated duty. AWS is only for core transaction processing and customer account operations. Google Cloud is anything machine learning and analytics, AI threat detection. Azure CRM, Microsoft Dynamics, CRM systems where the integration is so seamless, and all the business applications, go-to-market strategy, enterprise integrations, all um, stay in Azure. So, what does it mean? It means that by having the segregation of duties in the clouds, fraud detection performance increased up to 93% accuracy in detection, less than 1% false positive rate, and overall $5 billion estimated annual savings by fraudulent losses. How does this advanced fraud detection system architecture work? The real first thing is real time analysis. Any suspicious patterns, any threat patterns, they're identified in live streams with immediate quarantine capabilities, which means that your card is blocked, or immediately the access is restricted, or there is a time block until which, until the authorization comes in, the activity will not proceed further. So all these quarantine capabilities come into picture. Now, how exactly is this real time analysis successful? One is machine learning model layer. So what this layer does is it continuously trains on the data that we feed into it. What do we feed? All the historical fraud cases, and also it has adaptive algorithms that will evolve as the attacker tactics change. Along with this, there is behavioral analysis as well, which feeds into this layer, which means per customer baselines, detect account takeover and unauthorized use through deviation scoring. There's a deviation scoring, which is again done through some of the mechanisms and algorithms. Cross institution intel, which means the threat intelligence shared across financial institutions for industry wide pattern recognition, is also fed into the system to make sure the alerts are more accurate. This is how it's managing 30 million relationships, hundreds of petabytes. There are three architecture pillars for managing of this scale in JP Morgan Chase. One is horizontally scalable architecture. Workloads are distributed dynamically across systems, which means the individual nodes remain simple, while collective capability scales to peak demand. Multi-dimensional data partitioning. All the customer data is partitioned by geo, product line, risk profile, so that the limits are even if there's a threat actor, it limits the scope and accelerates recovery per partition, so the remediation can be quick. Automated remediation, right? Even if there's a threat actor, how is it going to remediate it? It halts the transaction, the customers get notified, the incidents get escalated automatically, so it's reducing the human intervention and also the response latency. Five recurring cloud CRM security failure categories that the industry has seen so far, and the majority fall into are: one is misconfigured access controls, your firewall settings, or any persona or profiles having excessive permissions. This will lead into cascading effects. Well, how do we mitigate it? We have to ensure that zero trust, which means that you don't give access even if the actor has got internal access. There is a per user authorization, per request authorization as well. Least privilege. Make sure that the access that you give to any applications or integrations are limited only to the scope that is needed, rather than giving supreme permissions. Automated access audits. have an audit all every time periodically, which runs saying that, oh, this system has, read only, or modify all permissions. Is it really required? The system has permissions into billing system. Is it really required? So make sure that these audits are automated. Inadequate data encryption, which means any sensitive data stored or transmitted in plain text, and even if the data is not masked in sandboxes, all of that comes into inadequate data encryption, which can lead to um, data exposure. How do we mitigate it? Encryption using the best algorithms, and there's no exceptions for performance while we do the data encryption. Even if there is a little lag, that is worth it. Insufficient monitoring. Some of the breaches, or most of the breaches, go undetected until external notification comes into picture. So how do we mitigate it? Instead of relying on humans for this one, AI powered monitoring will detect anomalies super fast, like 237 times faster than manual review. Weak API security. Any API is exposed without authentication or using the standard username password authentication, not having rate limiting or input validation can cost this one. How do we mitigate? Using the latest protocols, OAuth 2.0, having the correct web application firewall settings, gateways, comprehensive logging is also very important. And digital certificate used for handshakes. Poor incident response, slow detection and inadequate isolation amplify damage. And how do we mitigate? We have to have the playbook ready. We need to have regular drills for any security incident, and we have to have a routine established. We also need to have that pre-established forensic partnerships, and for other companies it could be pre-established escalation partnerships with executive leadership. Um, so the practical framework. So these are the 7 pillars for any secure cloud CRM. So previously we have seen what are the major categories where cloud CRM may fail, having security exposure. But if we now we are looking at the 7 steps which should be implemented for any secure cloud CRM, right? One is security by design, having that security hat on from day one, making sure that security is integrated into the design will eliminate a lot of security threats. It will not have any loopholes open in the basic fundamental design. Second thing, implementing zero trust architecture, which means you're verifying each and every request. Data classification and protection is the third one. You classify your data P1, P2, tier sensitivity, and controls you put into picture. Data masking in sandboxes, and wherever is needed. Fourth one is API security and third party integration. Identify all the external APIs that the system is calling, inbound or outbound, or even third party integrations using connected applications. We need to make sure that we follow the least privilege access principle while giving access to these integration users. Authenticate, authorize, monitor. Continuous monitoring and threat detection, which is the fifth step, which is weaving AI ML into the threat identification framework. It will give you super fast results, and it analyzes the real time behavior rather than reactive. It's more proactive. Sixth one is instant response and recovery, having your playbook and drill ready. Seventh step is compliance and governance, which is board level oversight, which prevents any shortcuts, right? If you have the compliance and the GRC set up, um, this will make sure that anyone under the executive leadership, they will not be following shortcuts, as of missing a specific step in getting the approvals of finance and pushing into production code, or enabling a feature without having proper requirements in place and audits in place. All of this can be avoided. Security and innovation, complementary imperatives, right? When it comes to innovation security, most people think that innovation security may hinder the innovation, but let me tell you one thing. So the cost of not being secure is cloud CRM costs anywhere between $4.545 million to $12.7 million per event. So prevention through proper architecture costs a fraction. This is immediate and durable return of investment. Proof is in the cases. We have seen Starbucks, Mayo Clinic, JP Morgan Chase are proof. Rigorous security and transformation and innovation are not opposing forces, but they complement each other and mutually reinforcing. evolutionary imperative, right? As AI, blockchain, quantum resistant encryption reshape CRM, security architecture also must evolve in every step. Stagnant security practices make organizations increasingly vulnerable to adaptive adversaries. Um, so, organizations that implement both security and innovation leadership will define their industries. Those that sacrifice either will face either, financial, regulatory, or existential consequences. So, for the question and answers, I think we have addressed these two important questions. What are the most critical security risks in AI powered cloud CRM systems, and how organizations can mitigate them? Are the five categories that we spoke about. And we have provided the mitigation as well on high level. What architectural best practices should enterprises follow to balance AI driven personalization with data security and regulatory compliance? Is the seven steps that we have just gone through. Um, and Thank you for giving me this opportunity, and hope you all have got a sneak peek into all the cases, and it helps evolve the security at your organizations. Thank you so much.